right, in this video, we're going to take a look at how to determine the amount of excess reactant that remains. So after a reaction occurs, the limiting reagent is used up, and the excess reagent remains. There's some left in there, not all of it, but some of it remains unreactive. So for example, if we look over here, we have the hot dog and the bun, and we want to make the hot dog bun over here, hot dog in a bun, so a full hot dog. So as you can see, the excess is going to be the hot dog. There'll be one extra hot dog left over. So what we basically said is that if we have 4 hot dog buns, well, they will react with 4 hot dogs. 4 hot dogs. Now we have 5 there, so we're just going to do 5 minus the 4 hot dogs that are going to be used up, and we'll have 1 hot dog left over. And that makes sense. There'll be one hot dog left over there because there's not enough buns to use up that last hot dog bun, that last hot dog. So here are the main steps when we're doing a chemistry problem for how to find the amount of leftover or excess reactant. We're going to find the moles of the excess reactant that would react or that will react with the limiting reagent, and we have to use the limiting reagent for that. We're then going to take the amount of ER or excess reagent given in the question and subtract it and subtract the amount that will react from that. And that'll give us the moles of leftover ER. And then once we're done, we can convert the moles to mass for the excess reagent. It'll make a lot more sense when we actually do an example. So let's go ahead and do that here. So example 4 is, here we are, aluminum hydroxide neutralizes hydrochloric acid according to the reaction below. If 0.5 grams of AlOH3 is reacted with 0.6 grams of HCl, predict the mass of aluminum chloride that can be produced. So let's start off with question A. It's just a basic limiting reagent stoichiometry problem. So we have aluminum hydroxide reacting with hydrochloric acid. And that's going to produce our aluminum chloride plus water. And I'm going to write it as HOH just because I like to have water written as that when I balance it. I do want to check my aluminum chloride state just to see if it's dissolved or not. I always forget that one. Soluble, yeah, it's soluble. Okay. So what's the mass of the aluminum chloride going to be? So first of all, let's make sure we have it balanced. So it doesn't look balanced yet, but we'll go ahead and do that. So we'll put a 3 there, a 3 here, a 1 here, and a 1 here. And now it is balanced. Let's go ahead and write down our information. We have a mass of 0.5 grams over here. And over here we have a mass of 0.6 grams. And we want to find the mass of aluminum chloride that will be produced, which is a mass times a molar mass. We know this is a limiting reagent problem because we're given the mass of 2 reactants, and we have to figure out which one's limiting reagent. And to do that, we have to compare them on a mole level. So since we're going to be using moles and masses, we may as well find the molar masses for the various components here. Let's do that with our periodic table. So for hydrochloric acid, we get 36.46 grams per mole. For aluminum chloride, we get plus about 133.33 grams per mole. For aluminum hydroxide, we get 78.01 grams per mole. And so we need to find the number of moles of each reactant so we can compare them to see which one is going to be our limiting reagent. So moles is equal to mass over molar mass, which is equal to 0.5 grams over 78.01 grams per mole. Cross the grams out, you're left with moles, and we'll get our value here. I'm just going to write this out as well over here. It's the same idea, mass over molar mass, but the mass of the HCl and the molar mass of the HCl. So 0.6 grams over the 36.46 grams per mole. Cancel out the grams, you're left with moles. All right, let's see what we get. So we have 0.5 divided by that 78.01. Whoops. 0.5 divided by 78.01. We get 0.006409434 moles. And we're going to try it for the next one as well. 0.6 divided by 36.46. And we get 0.0164563 moles. So now we have to compare these to see which one's limiting reagent. You cannot necessarily choose the smaller one because they react in a 1-to-3 ratio, so we have to double check which one it's going to be. So we can use any method we want. So let's determine the LR. So find LR. I'm going to do the method where I just compare the reactants to each other. Actually, you know what? No, I'm just going to do the simple method. I'm going to divide them by their coefficients. So for the ALOH3, I'm just going to do the 0.0064, so on and so forth, 0.9 divided by 1, and we get 0.006409. And then for the HCl, I'm going to do the 0.0164, so on and so forth, divided by 3, because the coefficient is 3. So I get 0.00548, and it keeps on going. So in this case, my smallest number is for the HCl, right? So notice that over here, since the 0.00548, which is HCl, is smaller than the 0.006409, HCl is the limiting reagent. So we found our limiting reactant. Great. So now what we can do is we can use our limiting reactant to solve the problem. So I'm just going to write here that this is the LR. Use LR to solve. So we can do our ratio. It's a 3-to-1 ratio between the LR and what we're looking for. So 3 HCl for every 1 AlCl3. So that means we're going to do 0.0164, so on and so forth. All my decimals are in the calculator, but I'm not going to write them all out there. Moles of HCl times 1 mole of AlCl3 over 3 mole of HCl. Cross out the moles of HCl, and so we get 0.0164563 divided by 3, and we get 0.005485463 moles of AlCl3. And now we can simply do our find the mass, because mass is equal to moles times molar mass, which is going to be equal to 0.00548. All numbers are still in my calculator. Moles times the molar mass, which is 133.33 grams per mole. Cancel out the moles and we get grams. So times 133.33, and we get 0.731376826 grams, which is approximately how many sig figs? So it looks like our hydrochloric acid was our limiting reactant, only 1 sig fig there. So to 1 sig fig, that would be 0.7 grams. So therefore, approximately 0.7 grams of AlCl3 are produced. That would be the mass of the AlCl3 produced. So that there is how you would go about finding your answer using a simple limiting reagent sort of problem. Now, what we want to do in this question, this is a bit vaguely, this is worded kind of vaguely. We want to say the amount of excess reagent left over. So let's go ahead and try that out. We want to figure out how much excess reagent is left over. So for part B, here's what you do. I'm going to use a different color. You use your limiting reagent to find out how many moles of the excess would have reacted. So I'm going to use this. I'm going to do a mole ratio to see how much excess would have reacted with that. So I'm going to do, my ratio is for HCl to AlOH, it's 3 HCl for every 1 AlOH3. And so I'm going to take my 0.0164 moles of HCl, and I'm going to multiply it by 1 mole of AlOH3 over 3 moles of HCl, because I'm canceling out the HCl. And so I'm going to do that value there, the 0.0164569 divided by 3 is going to be 0.005485463 moles of AlOH3 that should react with the LR. But you'll notice that we have more than that. We have 0.006409434 moles. So that's our next step. So this is step 1 to find how much should react. So now what we're going to do is we're going to do the what do we have from the question minus what should. So have minus should is what's going to be left over. Have minus should is going to be that 0.006409434 minus the should part, which is 0.005485463. And that's going to be how many moles will be left over. So minus, okay, let's do that, 6409434. And I get 0.0009237 mole left over. Now, typically they ask you to find the leftovers in grams. So we can do that. We can do our mass is equal to moles times our molar mass, which is equal to the leftover moles that we found here. 0.0009237 moles times the molar mass, which was 78.01 grams per mole. Cross out the moles there. So times 78.01. And we get approximately 0.072078951 grams to 1 sig fig, because that's how many sig figs we have in the problem. In our question, we have 0.07 grams. And so you can then make your therefore statement. Therefore, there are 0.07 grams of excess aluminum hydroxide. And so that was just an extra part to the problem where you need to acknowledge that once your limiting reactant runs out, your reaction is done, you made your product, but your excess reactant, there's still some left. And so we used our limiting reagent to see how much should react with it of the other reactant. And we found that what should reacted was 0.0054 moles. So what we actually have, though, in our lab is this many moles. We have more moles. So we just did a difference between them to see what's left over. So whatever doesn't react is left over. And so we did that. And we found our mass by just doing our moles times our molar mass, which is the moles of leftover that we found, times the molar mass of that leftover substance. And that gave us 0.07 grams to 1 sig fig. You can try example 5 on your own. And in the next video, you can check your work to see if you were on the right track.